of u. And in this case, this can become this. And this can become this. So because the function, the function of x, this one, y equals to function of x, this function is too complicated. So in this case, we want to simplify the equation. We want to simplify it. Then in this case, what we can do is we can declare a new variable, and we use the new variable to simplify this function. And in this case, we can take, so this derivative is very easy to get. So we can take the y against the u for the first derivative, and then this function this variable is also an easy function. So in this case, we can focus on taking the x derivative on the u. So and after we multiply it, then the whole thing equals to this, and the whole thing equals to that. Okay. All right. So this is a chain rule. These will be chain rules, right? In the derivative actually. Okay, this is the chain rule. So what we can do over here is that alright, that's I believe most of you don't remember this. So let's give you an example. If y equals to example for example, like this. Distance equals to x squared plus y squared, and take the squared. So in this case, if I want to get this, then the equation will be too complicated to directly solve that. So what we can do is we can declare u equals to x squared plus y squared. In this case, d equals to u squared. Okay? So in this case, what we can do is we can d partial u multiply partial u partial x. Okay? So the first one actually is the derivative of this equation. So this is very easy. Okay? So as you can see, this one will become this. Then multiply the second one. Second one is also easy because when you take the partial derivative on x, then you will get just 2x. It will be just 2x. And then, so as you can see, these and this can be removed, and this is this. So what you have is actually dx. Okay. Alright, so this is chain rule. This is chain rule. So hopefully you can refresh your memory with this. Okay, so let's continue over here. So in this case, the idea is the same. Let's take a look. So right now, this term is this. So supposedly, this should be, if we multiply that, supposedly this one will be, suppose, multiply like this, right? This is the v transpose, this is v. So directly take the derivative on that is a little bit complicated. So what we can do is we can transform that into, because this is what we want, right? We can transform that into this partial v first. can transform that to this. Right, this is also chain rule. So let's take the derivative on v first, and then take the derivative, the v will take the derivative on delta. Okay? So the first term over here, this, we know that this is kind of like v squared, right? The residual square. Right? This one is like the residual square. So if you take the take a look at this and we take the derivative, then it becomes something like this. And the 2 will be over here as a coefficient. And here you have the residual transpose. Okay? So I believe you can understand this, right? If you take the derivative on v, then it will be 2v, right? And but however, because right now it's the metric form, so it's a transpose. Right? It's a transpose. Right? So the idea is like that. So this is the, you can say this is the first term. Let me mark it with a certain color so that you can map them. This one is this, the red one, the red line. Over here is this one. Okay. All right. Then the second one is over here. Okay. So let's take a look. Next one. So the 2 can be removed. 2 can be removed because this is equals to 0, so 2 can be removed. And right now, if I take the derivative over here, this term, then as you can see, v equals to b delta minus c. Right? v equals to b delta minus c. And right now, if we take the derivative on delta, then what will be the outcome? B, right? So we have the b over here. So it will be v transpose multiplied b equals to 0. Okay. And here is this one, this one, this one is this one. Difficult to understand? Oh, really? Why? Okay. Which part? Which part you guys don't understand? Which part? Angie, which part you don't understand? Starting from where? Starting from where?
That part here from.
Here, this part. Oh, okay. Okay. I will go over this again. Okay. So the least squares adjustment. This should be fine, right? So if you want to find the most probable value, you want to find that a certain value that can make the residual square summation minimum. Okay. And the residual summation, residual square summation is the v transpose multiplied v. And this one should be fine, right? This one should be fine. Because this multiply this, then it will be v1 multiplied v1 plus v2 multiplied v2, and that will be the summation of residual square. So this one, because we want to find a certain value, and the unknown right now is delta. So we want to find a certain delta that can make the summation of residual square minimum. So like we say, if we want to find the extreme value, we need to take the derivative. We need to take the derivative and then equals to 0. And we are finding the extreme value. Right? We are finding the extreme value. So which means that we need to take the derivative of delta for this. Okay? Then it will be equal to 0. And this one is difficult to directly take the derivative. So we are going to, so here we apply the chain rule to make it easier. We apply the chain rule to make it easier. And what chain rule is over there. So as you can see, let's just use this example. If right now we want to find the answer of d and take the derivative on x, and as you can see, this equation is too complicated to directly take the derivative on x because you have square over here and the skirt over here, so it's difficult to directly do that. So what the chain rules means that it can help us to simplify the equation. So we we declare a new variable, which is u, and u equals to x squared plus y squared. So in this case, the d equals to u squared. And so the chain rule is, so this is the chain rule. So if we want to solve this, then we can declare a certain variable and then take the derivative on that certain variable. And later on, that certain variable will take whatever you want to take as the derivative. And so it will be like this. That's the chain rule. So in this case, as you can see, even though the first equation is complicated, but however, if we separate it into two equations, then it will be very easy. Okay, so here, the same idea is, right now, this is a little bit complicated. So let's separate it into two terms. One is, let's say we can take the derivative on v first. And as we know that on v first, and v can take the derivative on delta. So it's the chain rule, right? So from this to this, any question? Anyone? Raise your hand if you don't understand. That's good. Okay. Okay. So in this case, let's take a look at the first term over here. And we know that v transpose multiplying v is the residual square. We know that it's the residual square. So if we have the residual square and we take the residual as the derivative, then in this case, the square will be moved to as the coefficient 2 over here. And the remaining is the residual. Okay? So that will be the red to this red. Alright, for this step, any question? Alright, yes.
So why the b squared comes to bt?
Why this becomes to this? Because right now it's in the metric format. So as you can imagine, you can say this one is more like b1 squared, b2 squared, bn squared, like that. And we are taking the derivative on this. So which means that we are taking the derivative on each of the b. So it should be b1, 2b2, 2bn. So this will be 2, b1, b2, and bn. Sorry, b2n. b2n. Okay, b transpose. Okay. You mean why it has a transpose?
Yeah.
Why it has a transpose? Okay, how to answer your question? Why is not that? In my personal opinion, because later on you are going to multiply. Well, of course. First of all, I will going to make sure of that. So, however, here later on you are going to multiply with another term. So in this case, the derivative is supposedly it should be like the transpose over here, but we can take a look. Let me take a look and then let you know about why it should be transposed instead of like the general, like the original vector. Okay. Right. Okay, so basically it's like this. Right? So it becomes 2v transpose over there. And then the next step is over here. So the v take the derivative on delta. And this one should be an easy one because the v, if you take the derivative on delta, then you don't need to take the at the c. And right now the only thing that will left is the b. Okay, so it will be b over here. So it will be the equation can be summarized into v transpose multiply b. Okay, any question? Okay, that's good. So let's move on. So this can be modified as V transpose equals to 0 transpose. Right, let's take transpose on both ends. Right? So, and then the next thing is the V equals to this. V equals to that, right? So let's put B delta. Let's see. B transpose 0 transpose. Oh. So it should be B transpose. B. B transpose B delta minus C. Right, it should be like this. Right. And then the next thing is, you can see it will be B transpose B delta equals to B transpose C.